Hi guys, I'm going to show you how to do basic integration with the basic rules, some powers and some trick. The kind of stuff would find table in integrals. If you don't know what I mean by integration rules or table of integrals, then you are in the right place. Let me show you how to do it. So what I mean by integrations, everyone know that integration is the reverse or inverse of differentiation. So the integration is the opposite of taking the derivative. So first of all, what's meaning of the basic rule of integration? Everyone know that from grade 11, when we integrate x to the power n, or if you want to integrate x in x to the power n notation, we're just adding 1 to the power, then dividing by a new power, all of that plus c. And also, if you want to integrate any constant value, we just multiply the constant by x, all of that plus c, where c is the constant of integration. Now we are going to talk about what is the basic rule of integrals. As you see, 1 over x, bracket involving ax plus b raised to the power n, e to the power ax, sine ax, cosine ax, sec squared ax, cosec squared ax, that is called the basic rule. Why it's basic rule? Because it represents the linear function. Look at x here, x raised to the power 1, x inside raised to the power 1, x here 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 to the power 1, x here to the power 1. So the whole function of an x here is linear. So the integral of 1 over x, it will be ln for modulus value of x, all of that plus c. Why? Because everyone know that the derivative of ln x, it's equal 1 over x. So here we differentiate. In the opposite direction, we just integrate. So the integral of 1 over x, it will be ln modulus value of x. Why? Because any value inside modulus must to be positive. Okay, what if you have bracket involving linear expression like that? We just adding 1 for that bracket, ax plus lp all to the power n plus 1, and dividing by a new power, n plus 1, and also we dividing by the coefficient of x, which is a, all of that plus c. The integral of e to the power ax, it's copy paste. Then we divide by a coefficient of x, which is a. Always we divide by the coefficient of x. Integral of sine, it's negative cosine ax, and we will divide by coefficient of x, 1 over a, all of that plus c. Integral of cosine, it will be sine ax, and also we divide by a, all of that plus c. Integral of sec squared, it will be tan ax, when also we divide by 1 over a, all of that plus c. Integral of cosec squared, it will be negative cotan ax, 1 over a, all of that plus c. So that is called the basic rules of integrals, or the standard rules of integrals. Why? Because the all values of x raised to the power 1. Okay, what if it's not raised to the power 1? In this case, we will use something is called recognizing or method. And everyone know that I have 3 methods: substitution, parts, and partial fractions. So it's good. First of all, if you got question like that, find the following integrals. I have integral for 3e to the power 3x. So everyone noted that. The function here in the power, it's linear. So we just use the formula. It will be 3e to the power 3x. And we will divide by a coefficient of x, which is 3, that number. All of that plus c. So finally, it will be equal 3 divided by 3 cancelled. So the final answer, it will be e to the power 3x plus c. For the second one, or letter P, I have definite integral. And definite integral means I have limits in that integral. Integral from -6 to -3 for 1 over x respected to the x. As you know, integral of f prime x respected to the x, when the integral defined from a to b equal, the integral of f prime give us f of x defined from a to b. To evaluate the definite integral, we just do that, open two brackets, and between that two brackets I have minus. In the first one, we substitute every x by upper limit fp. In the second one, we substitute every x by lower limit, which is f of a. So here, what we want to do here, we just need to integrate that 1 over x. It's a standard rule because x here to the power 1, so it will be ln modulus value of x. It's defined from -6 to -3, and as you know, we open two brackets. Between these two brackets we have minus. In the first one, we substitute every x by upper value, which is -3. In the second one, we substitute every x by lower value, which is -6. So everyone need to note that here. The modulus give us only positive value, so it will be equal ln3. So modulus of -3 equal +3, because the modulus give us positive value only, minus ln, the modulus of -6, it will be +6, and as you know from first semester, minus between two logarithm means I have division of inside. It's ln3 over 6, so it will be ln 1 over 2. We are going now to the third one. Integral of sine x. First, we check for that function inside. It's x to the power 1, so it's a standard. So integral of sine, it will be negative cosine x. And coefficient of x here is 1, so 1 over 1 equal 1. All of that plus c, I got the answer. Now we just need to take some hints about the integral of trigonometric functions. Everyone noted that here in trigonometric function, I have integral for sine and cosine only. And for quadratic trigonometric function, we have integral of sec squared and cosec squared. So we just need to use the identities or trigonometric identities if you want to work with some important points. Remind yourself, everyone know that sine squared x plus cosine squared x is equal 1. And we can use that identity to get sine squared x equal 1 minus cosine squared x, or cosine squared x equal 1 minus sine squared x. We use that rules if you have integrals like that. Find the integral of cosine squared x divided by 1 minus sine x, for example, respect to the x, or integral of sine squared x divided by 1 plus cosine x respect to the x, or integral of 1 over sine squared x minus 1 respect to the x. If you got like that question in the final exam, so you need to use that identity. How that, mister? As you know, 1 minus sine squared can be factorized as difference of two squares to be 1 minus sine x times 1 plus sine x. And also here, 1 minus cosine squared can be factorized as 1 minus cosine x times 1 plus cosine x. If you got integral involving sine squared or cosine squared in this form, or this form, or this form, so that means you need to use that identity. For example, here, I will substitute sine squared by its value. it will be 1 minus cosine squared x respect to the x divided by 1 plus cosine x. Now, we factorize the numerator here as difference of 2 squared. It will be 1 minus cosine x times 1 plus cosine x, all of that respect to the x divided by 1 plus cosine x. So we noted that here 1 plus cosine x divided by 1 plus cosine x, it will be cancelled. So the integrals will be integral of 1 minus cosine x respect to the x. Now integrate 1, it's x. Integral of cosine, it will be sine x, all of that plus c. Also in this way, I have here cosine square over 1 minus sine x. We have one way to get the answer, to use the quadratic identity. Why? Because we can use difference of 2 squares to remove the denominator. It will be integral of cosine squared, it will be 1 minus sine squared x divided by 1 minus sine x, all of that respect to the x. Now start to factorize the numerator. The denominator goes down. It will be 1 minus sine x times 1 plus sine x as a difference of 2 squared. Here 1 minus sine x divided by 1 minus sine x, it will be cancelled. So the integral, it will be 1 plus sine x respect to the x. Now we have a rule to integrate. Integral of 1, it will be x. Integral of sine, it will be negative cosine x, all of that plus c. Also on the third one here, 1 over sine squared minus 1. Everyone know that sine squared or cosine squared equal 1 minus sine squared. Here I have sine is different. It's a sine squared minus 1. So we can substitute that by integral of 1 over, it's represented by negative cosine squared x. Why? Because cosine squared equal 1 minus sine squared. But here it will be sine squared minus 1, so the sign it will be changed. So you need to put negative here. Okay, mister. Then what we have to do? Everyone know that 1 over cosine squared, it will be sec squared x, and don't forget negative respect to the x. And we have rule for integral of sec squared, it will be that negative is tan. Integral of sec squared, it will be tan x, all of that plus c. Okay, what if you have integral in that form? Integral of sine squared to x respect to the x. In this case, you need to use that rule. Using a double angle formula from first semester, sine squared x is equal 1 over 2 minus 1 over 2 cosine 2x. And the cosine squared x, it will be equal 1 over 2 plus 1 over 2 cosine 2x. I have same rule, but only sign is different here. That from double angle rules from first semester. We use that rules if and only if you have question like that. Integral of sine squared. So we can do that here. It's equal integral 1 over 2 minus 1 over 2 cosine 2 times angle. The angle here is 2x. 2 times 2x, it will be 4x respect to the x. Now we change the integration to be in a simple rule. Integral of 1/2, it will be 1/2 x minus integral of cosine, it will be sine 4x, and just divide by coefficient of x squared. So coefficient of x here, it will be 4. 1 over 4 times 1 over 2, it will be 1 over 8, all of that plus c. By the same way, if you have question like that, integral of sine or 3 sine squared x plus cosine squared x, 3 cosine squared x respect to dx. And we can change something in that question to be like that, integral of 3 sine squared x plus 2 cosine squared x respect to the x. What is the difference between these two questions? If he said work out that integral, what is the difference between these? In the first one, I have 3 here, and here also it's a 3, so I have same number, so we can take 3 as a common factor here. So I got sine squared x plus cosine squared x, all of that is equal respected to the x. So everyone know that sine squared plus cosine squared is equal 1. So to change it to be 1 times 3, it will be 3 dx. And integral of 3, it will be 3x, all of that plus c. But if you get two different numbers or two different digits here 3 and here 2, we cannot take as a common factor like the previous one. So what we have to do in this way, we just need to substitute using the values of sine squared and the cosine squared using the relationship between the double angle formula. So it will be 3. We substitute the first one. It will be 1 over 2 minus 1 over 2 cosine 2x plus 2 times, we substitute here also, it will be 1 over 2 plus 1 over 2 cosine 2x, all of that respected to the x. Now that number, it will be distributed 3 times 1/2, it will be 3 over 2. 3 times negative 1/2, it will be negative 3 over 2 cosine 2x plus, by the same way, we multiply 2 by half. 2 times half, it will be 1. 2 times 1/2 also, it will be 1 cosine 2x. All of that respected to the x, and don't forget to put all of that inside bracket. So everyone noted that. I have like terms, 1 cosine 2x here, and negative 3 over 2 cosine 2x, and also we have another like terms, constant value here and constant value here. We just collecting the like terms, so it will be equal integral of 3 over 2 plus 1, I think it will be 5 over 2. Now 1 cosine 2x, that is 1, minus 3 over 2, it will be negative 1 over 2 cosine 2x. Now we reach to the more standard formula. Integral of any constant equal that constant times x minus integral of cosine, it will be sine 2x, and divide by 2, 1 over 2 times 1 over 2, it will be 1 over 4, all of that plus c.